Today, one of the most preeminent thinkers there is the Argentinian physicist Juan Maldacena. Quiet and softly spoken, there are many other physicists who are brasher or louder. Few are deeper. And so it was in 1997 that Maldacena, buried in profound thought on the physics of brains, introduced a striking new idea. Whereas M-theory seems to have been named with an eye for the attention it may bring, this idea had a far more humble moniker: the AdS CFT Correspondence. This correspondence is probably the most important theoretical idea to have emerged from string theory in the last 30 years, for it leads to a profound re-evaluation of what gravity means, and also what a dimension of space means. Maldacena's remarkable insight had originated from thinking about what physics would look like to a hypothetical observer moving extremely close to a brain. There were, he argued, two possible ways of thinking about this. In the first, he imagined life on the brain, looking at all the physics in terms of fluctuations of the surface of the brain. Physics, if you like, perceived by the water boatman on the surface of the pond, and how these fluctuations interacted with themselves and each other. In the second, he imagined the brain as a gravitational object within a larger space-time, with the description now all governed by the higher dimensional theory of gravity, physics viewed by a higher dimensional external observer peering down at the surface of the pond. Maldacena's key insight was that while the actual physics had to be ultimately the same, these two different observers would use very different equations to develop these same physics. The observers living on the brain would describe these physics using a non-gravitational theory, a theory analogous to those used to describe the Standard Model. The second observer, the person peering close to the surface of the pond, is the external one in the bulk. This observer sees the brain as a gravitational object within space-time and describes all of the physics near it using a gravitational theory, a theory which uses all of the spatial dimensions of the brain itself, but with one extra spatial dimension corresponding to the vertical direction perpendicular to the surface of the brain. Maldacena realized that as these two theories describe the same physics, they must always give identical answers. Even though the descriptions of the two different observers appeared very different, there was only one physical system, and so the results they gave must be the same. Whatever the process, for any physical quantity one could compute in this system, there would be two different ways to obtain the answer. The first using the theory of the first observer, similar to those used to describe the strong force within the Standard Model, while the second was a purely gravitational theory involving an extra dimension of space. Perhaps Maldacena dared to dream it was because these apparently different descriptions were actually the same theory. In the terminology of physics, the two accounts were dual to one another. Any calculation you could do in one, you could also do in the other. Famously, the Rosetta Stone allowed Egyptian hieroglyphics to be deciphered through the knowledge that the information on the stone was the same in all three of the languages used. A duality is like a scientific version of the Rosetta Stone, where exactly the same information is present, except presented in different languages. Here is one quantity computed with this theory, a product of a heroic calculation to levels of accuracy that go beyond any of those achieved within the Standard Model of particle physics. If you were asked to write down a random fraction, you would not be writing down these. There is no way you could write down this expression by chance. This expression arose as a result of the calculation in physics as perceived by the observer living on the brain, looking at the brain as a surface under tension which fluctuates, although in this case the surface is a four-dimensional hypersurface. According to Maldacena's duality, this calculation should be precisely and totally equivalent to a calculation done in a five-dimensional gravitational theory. And this calculation has also been done, exactly the same. All the complicated structure of the first calculation, worked out in the four-dimensional theory for those living on the brain, is reproduced by the second calculation, done in a five-dimensional gravity, which views the brain as a gravitational object inside a higher dimensional space-time. But what did this all mean? To understand this, we must first understand something about one general property of quantum theories. Some theories are more quantum than others. For some descriptions of physics, classical physics works extremely well. To describe how gravity affects a ball thrown in the air, we do not need to use quantum mechanics. Although quantum effects are there, they are so utterly tiny that we can entirely neglect them. Near a black hole singularity, quantum effects may matter in gravity, but for most purposes, they are minuscule. But for other theories, the quantum nature of the system is crucial to everything. For physicists trying to understand the details of the strong force inside the standard model of particle physics, the quantum effects are always large. And this was the surprise. For a pivotal feature of Maldaceno's duality was the equivalence, the sameness, between a gravitational theory in 5 dimensions and a non-gravitational theory in 4 dimensions. It was a shocking claim that initially appeared to physicists as complete nonsense. A gravity theory in 5 dimensions being the same as a non-gravitational theory in 4 dimensions, it made no sense. But this was the key. The fact that on first appearance the claim was bizarre and obviously wrong is what made its truth so profound. Ever since it was first proposed, the evidence for Maldaceno's bold conjecture about the physics of brains, the AdS CFT Correspondence, has piled up, and this evidence has shown again and again that brains in string theory are mathematically and theoretically consistent, even if we still don't know whether they relate to the real world. Whatever our initial skepticism, whatever our initial surprise, it seems that at least this duality is, on a mathematical level, true. Radically different theories can, in fact, carry the same information in different languages. There was no way that this could have been chance. Clearly, manifestly there was a deeper structure, a deeper, consistent structure that explained these mathematical connections. Very different starting points, very different calculations, but ultimately the same answer. And most importantly, for our understanding of the world, this could only happen if the brains of string theory were real, consistent objects. Of course, whether M-theory is ultimately the consistent theory of our world, we do not know. Yet. But we do know enough to say that it is a consistent theory of something. Deep ideas lurk behind the symbols. Space